introduce to you Thomas Steiner. So Thomas is a customer solution engineer with Google. His main interests these days are JavaScript, Ajax, Google APIs, and social web. In the past, he has led several open sources projects like REST, REST Describe and Compile, code generation for REST-based APIs, or API-lity, I think we'll talk about it later, PHP client library for the AdWords API. I'll do it in Hebrew as well. תומאס סטיינר. תומאס הוא מהנדס פתרונות ללקוחות, העובד במשרדי גוגל בהמבורג. תחומי ההתעניינות העיקריים שלו בימים אלו הם API, Ajax, JavaScript של גוגל ו-Social Web. בעבר וכן בהווה, תומאס מוביל מספר פרויקטים בקוד פתוח, כגון REST-based APIs, REST Describe ו-API-lity. תומאס, please.
שלום, סלאם עליכום. קוראים לי תום. ברוכים הבאים ל-GWT session ב-Google Developer Day. מה נשמע? אחלה. מצטער, זה כל העברית שאני יודע. So thank you and welcome again very much to my talk today on Google Web Toolkit. My name is Thomas Steiner, as I said before. I'm based in Google Hamburg, so I'm really happy to be here in Israel today. We're going to talk about Google Web Toolkit and measuring milliseconds. So this is, well, most part of it is really about Web Toolkit, but some techniques are also for general Ajax applications, how to speed them up. So let's dive right into the talk. Well, JavaScript has been around for a while, and so yeah, people started using it, and at some point people started doing things like if Firefox do A, if Internet Explorer do B. That's not really the way we want it to be. Thank you. Yeah, I'm a dancer, so I really love walking around and doing things more in a mobile way. So yeah, people started using libraries to overcome things like if Internet Explorer do this, so people would just code against the library. I have a question to you. Who of you has done like JavaScript development in Windows Notepad or so? I have. Who of you thinks it sucks? Well, not it sucks. Who of you thinks web development should just not be like that? So we at Google thought the same way, and so our engineers went for the creation of Google Web Toolkit that allows you to basically write JavaScript applications in Java. And if you write in Java, there probably comes up Eclipse in your mind, or like IntelliJ or so. So for Java, we have really, really great IDEs, so integrated development environment, where you can simply refactor with a mouse click and stuff. And like in Windows Notepad, it would be like search all variables, name A, rename them to B. And if you have like a huge project, you're tempted to do like, okay, I'm really sure I have used this name just in the functions ABC and so on. So you click on replace all. Who of you has done this before? I have. And who of you at some point noticed that, well, actually you have messed up your project? I have many times. So I'm really happy that now we have IDEs, now we have now we have Eclipse to work with Google Web Toolkit. So this slide, yeah, is basically about the message GWT can help. Next slide. Oops. Who of you has seen this before? Stupid question. All of us have. With Google had a look at some research that others have been doing about like site responsiveness. 0.1 seconds is like where people really think, okay, the application reacts in real time. So you click a button and something happens. Within 0.1 seconds, the application really feels like, okay, it's doing what I tell it to do. 1 second, people start like, okay, there's a smart delay, but still it's responsive. So people wait the second and then go for their action. So it's less intuitive, but still the application feels reactive. 10 seconds, just forget about it. But actually, many Ajax applications these days have this spinning, loading for 10 seconds. So it's not really what you want to do in your application development. So there's performance tips. What can you do? And actually, where can Google Web Toolkit help? Basically, there are three ways you can start optimizing. You can start optimizing at compiling time. So remember, Java is compiled into JavaScript. So you don't write JavaScript directly. You write Java, and the compiler does all this stuff for you. So where can we do things at compile time? Then the next is the network. Bandwidth is really, really expensive. I have a fast DSL at my place, and it's still too slow. And I got like one of these devices, mobile phone. Well, it's really slow. It's fast. It's 3G, but it's okay. Could be better. So bandwidth is really expensive. So you want to make sure that the data you shift over from place A to B is really a small amount, and that you reduce the number of HTTP requests and so. And then finally, the user interface. There's many like tabbed applications where you have, I don't know, hotels. So you have the hotel, and then you have the reviews, and then you have where is it located and stuff. So if you load all this in one page, it will be really, really a lot of data. So yeah, how can we make sure that people only load what they see at a time? So make sure that the application loads fast. So let's dive right into the first bullet point. Let's see what we can do at compile time. So Java is a statically typed language. This allows you to say, well, this value is an integer. JavaScript is dynamically typed. So you just have, this is a variable, and you can put whatever you want into it. Like basically, everything is an object. And Java is statically typed, so you can make sure that in a language, you just, in a variable, you just put what is allowed by the language. This includes that we have no runtime reflection. Could we turn this mic off because it creates some weird echo? And then we can do this and optimize through the whole process. So let's have a look at how Google Web Toolkit does this. Let's make all the bullet points appear. First, we start with building an abstract syntax tree, an AST, in the Java code. And then we do things like pruning, recomputing finality, devirtualizing and stuff. This is more like abstract for the moment. So there's a huge list of stuff we can do. We will jump into some of them right in a few seconds. So once we've done this, then we generate the output. So this is all stuff done by the compiler. This is nothing we have to worry about as developers. This is something Google Web Toolkit developers, like on the Google side, had to worry about, how to build the compiler in a really intelligent way. And they've done a really great job on it. So prune unused code, dead code elimination. Let's make all of this appear. Oops, this will run too much. Okay, so Java list, it's one of the Java libraries, and there is 23 methods in there. But in your program, you use just, say, in this case, 4 or 5 of them. So there's really no use to compile all of Java list into JavaScript. It's only about you compile what you need. So your source code gets as compact as possible, just because the Java compiler notices, well, the JavaScript compiler actually, notices that, well, there's some parts of code that you don't use, so we won't compile it. And it comes for free. So next thing you can do, this is a shape function where you can calculate the area. So you have some shape, and then you can calculate the area. that's a function call. You as a Java programmer, you would really write like that. But some of these functions, well, they're basically just one line. So the overhead of calling the function adds a lot of, like time that wouldn't be needed. So what the JavaScript compiler does is it inlines some of the actual calls. So if you have a look at the function now, in area equals 2, and then we have simply inline what the function does. But again, you as a programmer, you do the above box. Then happens compiler optimization. So you really program in a clean way, but the compiler makes it as fast as possible. Who of you has done string concatenation, like building small parts of strings into bigger parts of strings? All of us have. And Internet Explorer had this like weird string concatenation issue. So you simply couldn't say ABC plus DEF and build a string, because if it did this for a huge amount of string data, this would just slow the process. So people came up with this, like, put things in an array, and then at the end join the array. This was like, okay, this is the ultimate optimization for concatenating strings. But I mean, it's not really what you think of you should be doing, because actually you just want to put two strings and build them into one. So why introduce an array and stuff? So the message is, with JavaScript, you can do it the right way, that like the way you feel it, and the fast way. So you as a JavaScript compiler probably don't want to do this. So there's a way for optimization in the process. And the next is, well, Firefox behaves differently than Internet Explorer for like inner tags versus text content. So you had to do like, if Internet Explorer do this, if Firefox do this, and it's really not what you want to do. And then finally, users might have very specific needs. If I'm watching some website on a desktop computer, or if I'm watching some desktop, some website on like a small computer, as an iPhone, for example, the website could behave differently. Like you could offer a special version for small devices based on the user agent. And if me as a German user looking at some Israeli page, and this site offers the German version, I don't care about the Hebrew translation. Same goes the other way around. If a German website offers a Hebrew translation, you don't care about the German content. So different users from different locations have different needs. So you really want to make sure that all these users just download the content that is relevant to them. And yeah, same goes for network. If you can detect that it's a slow network, you might like degrade gracefully and have like low-res graphics, for example. So one code base doesn't fit all. That's the main message of this. And yeah, that's the same. If you have this, if Internet Explorer do this, if Firefox do this, people at present usually download all of this code, and like, I don't know, 20% of the code never gets executed because it's for the other browser. So what can we do about this? We're talking about Google Web Toolkit, and Google Web Toolkit is about Java. So we have a single Java code base, and then what's happened is really interesting. You just download exactly what you need for your browser, for your location. So let's say I'm a Firefox user, and I'm based in the United States. I just download the version that gets compiled exactly for this combination. So I just download Firefox 1.0 code, and I just download the NUS local file. But then there comes the second user based in the UK, Internet Explorer 6 user. So this person would just download a different file that is optimized for this combination. And we can go on like this, several combinations. And you can quickly think of, this is a combination problem. Like you have language and you have browser version. And this makes a lot of combinations. And you as a developer don't have to care about this. All this combination fiddling around is done by the JavaScript compiler. So you just work with your single Java code base, and then you get all these combinations for free. And the advantage is all of these users, like if I'm the user with Opera 9, French, I I just download what I need. So really, really good optimization technique, and it comes for free. That's the best message about it. Yes? This is the next point, yeah. The question was, when is this decided which version to serve? Well, let's go back. Thing is, you can see like all these different combinations have different file names. They have very like MD5 encrypted file names, so each of these is unique. And then what people would do is they would just have one decision script that does all this if Internet Explorer, if whatever browser, then download D415, D917.cache, and so on. So there's one small decision script that does all this. Okay, what browser is it? What local is it? And then download just the one version. And you can see the file extension is .cache.html. You can really, really cache these files. There's no worry about it. Because if next time you come and someone has changed something on the application, because with the MD5 encryption, the next version would have a different file name. So you really can be sure that each time the user reloads and you have done some changes to it, the user will get the latest version. And if there haven't been no changes at all, you can just serve the same file again, and people have cached it locally. So that's a really good way to make sure that people always get the latest versions of your website. Yeah, you should be coding just against an abstraction. Let's have a look at this example. In Java, you have this function set inner tags. So you have a div, and you can set the inner tags. This would work differently on various browsers. Like in Mozilla, we have the native function text content. In Internet Explorer, we have inner tags. Basically, they do the same thing. They put a string into the content of this div or whatever element. But you as a Java developer, in this case, you just write against the abstraction. So you just use on whatever element dot set inner text, and that's it. You don't have to worry about how it works in different browsers. And yeah, this is what I was talking about. Then the versions get optimized for the various browsers. So Mozilla version, .js, Internet Explorer version. So you really can be sure that, yeah, the right browsers get the right content. Yeah, we have the how permutation gets selected slide now. Basically, there is one file, no cache, because you really want to make sure that each time this file changes, you need to update the map, like with the various MD5 encrypted file names. So this is a file that people should download every time. Like if you change the application, your encrypted file names would change as well. And in the lookup script, like in this decision script, you would have to make sure that in the new version, there's the new mapping. Like if Internet Explorer and English do this. So each time you want to make sure that this is the latest version. Yeah, and then just one of the versions gets selected. So internally, it looks basically like this. You have a map with various combinations. So you have the languages and you have the browser versions, and then you can see the file names that will be loaded. And then once this is over, we compute the final file name, like the combination of local and user agent, and then we get the right versions. So I hope now the question is really responded. Yeah? Good. This allows for perfect caching. We've been talking about it. What we use for file names is basically the timestamps. So we have a timestamp, and then we MD5 encrypt it. So you can really be sure that each time you do some changes, yeah, the right version gets selected. So this was about compiling. We've seen that all these optimizations come for free. It just gives you an idea of what goes on behind the stage, what goes on that you don't have to care about. Next thing is memory is cheap, disk space is cheap, and we have said it before, network bandwidth is really expensive. So let's see what we can do about it. All the browsers had this limitation of 2 HTTP requests at a time. Newer browsers, I don't really know from what version starting on, but newer browsers allow up to 8. But if you have like 23 separate files, like the images, the JavaScript, the CSS, the main HTML, and stuff like that, you quickly have like 32 pages, 32 files. And even with 8 connections, you still need to load them seriously. So you have 8 blocks of 8, blocks of 8, blocks of 8. So you really want to make sure that you reduce the number of HTTP requests. Let's see what Google Web Toolkit can do about it. First thing is you can inline this selection script. So in your main HTML, you have to include the selection script that basically selects one of the combinations we've seen before. If you inline this script directly in main HTML, you can already reduce the number by 1. So it's really a cheap thing to do. Next thing is we have web applications today, and applications usually have like icons. So in this case, we have draft, home, some envelope to, I don't know, whatever, emailing application, for example. So what you can do is you can combine all these graphics into like a bigger image, and then just serve the right extract of this image. You can say, well, wow, that's a great technique, but it's like I have to calculate the image sizes. Then I have to make sure that the the CSS like slices get picked correctly. So doing this manually basically sucks. Google Web Toolkit allows it to do it basically for free. So let's see how it works. You start with some code where you extend from image bundle. Well, in Google Web Toolkit we call this kind of image combinations image bundle. You give it a file name, and then basically you add all the files to the image bundle. And then what the compiler will do is, just create the CSS magic that will select the right slices for each of the images you put in the file. And you as a Java developer, you can basically work with the images as they were, like home.gif, drafts.gif. They're objects for you as a Java developer. But then in the background, all this Java CSS, whatever magic happens, and you don't have to care about it. So really great technique that comes for free. Maybe one last note. You might be tempted to say like, okay, I have this photo displaying page, and you have the navigation at the menu bar, and then you have all the photos. Probably, you could combine all these to a huge image, but that's not what you want to do. Why not? If you have a look at the file name of this image bundle, it's whatever MD5 encrypted .cache.png. First it's basically more for combining smaller images, for icons. And if you search for images on Google Image Search, for example, so you search for images of a cat, one of these images won't turn up, but you as a photo website probably want to make sure that your images of, I don't know if you have this cat photo website, your images of cats are indexable. So these kind of images are not indexable. Well, they are, but it doesn't really make sense because they're a combination. So just put smaller images in there, like icons, like smaller stuff that gets on all websites. And make sure that photos and the images that you want to have like as a separate entity don't get in image bundles. Already with the small icons, you can save a lot of HTTP requests that would just go on the wire for, I don't know, small 2K images. And then, some of you probably have created Ajax applications that need to load data at start time. So, I don't know, you have this stock ticker, you load the main site, and then you start loading the actual data. This, sums up the loading time of the initial page and then the concrete data loading time. So one good idea is to have some default values, like if you have a cookie, you can store the values of last time so that people see at least something. Like you display the graphs until you can, like until yesterday, for example, and then just load the missing pieces of data. So the messages have something like a get startup data function that would just have the initial data and then download the latest data. Of course, there is some cases where you cannot do this, but in general, it's always good to have the snapshot of yesterday, the snapshot of the last visit, and then just use it with the next visit. JSON. Who of you uses JSON? Okay, that's good. Basically, for those of you who don't, it's one way of transforming XML into some in a more compact way, in a more compact notation. So if you have a look at the first getMyJSON function, we have some object, we could call it friend, where you have first name, last name, and hobbies. So hobbies is an array of what this person likes to do. JSON is kind of tempting because JSON in JavaScript can be evaled, so evaluated. Who of you has done eval and then the JSON object? I have. Who of you has this kind of code running on a live website? Hopefully none of you. Why not? Because, well, all this evaluation magic really executes the code if something goes wrong. So if people if people insert by some kind of third man in the middle attack objects that have dangerous content in their JavaScript that calls whatever passwords function and logs all your passwords, they could be sent to third parties. This has happened before. You can just search for JSON insertion, whatever, attacks, and you will probably find some of these techniques that help people to make their site hacked. How can we do it? In Google Web Toolkit, we have the JSON object that basically provides a safe way to access data in JSON object. So let's have a look at how this worked in April, in the old days, more or less. You would start with the JSON object, and then on this object, get, and then the object key name is string, so you want to make sure that it's a string if you want to build a string in Java, and then you get the actual string value. So it's safe, but it's pretty long. So same goes for the array. You check for if it is an array, and if it is an array, then you can iterate over it and get the content. So it's safe, but it's pretty long. So we thought, what can we do about it to make it shorter? This brings in overlay types. An overlay type is basically a type that you put over a JSON object. So the loose structure of a JSON object suddenly with overlay types gets a real structure. So you can say, this is an object of the class friend, and it extends JavaScript object, and then you can say, well, this object has the attributes first name, last name, and hobbies. And like this, you can really make sure that the objects just have these kinds of fields and nothing else, nothing more, nothing less. And you can type it, so you can say last name and first name is a string, and the hobbies is an array. And if like this, during your application runtime, you try to modify these kind of objects and put a function, for example, in last name, this won't work. So the compiler would detect, okay, this is not of type string. So you get type safety by this kind of architecture. And now let's see how it works with the new way of coding. You just use the function. So we have f, which is the object, get my friend, and you say get first name, and you can be really sure that what comes back is a string. Same goes for the array string, get hobbies, and you just get the hobbies as a string. So this really adds a lot of type safety to something potentially dangerous like JSON. And well, this goes without performance penalties. This is the way the compiled code looks like. So you have the object, and then you just access the fields as you would do if you write it by hand. But actually, what the compiler does is this. But if you really look behind the scenes, it does this. So this function gets really, really small, really compact. You have obfuscation, so long file names, long field names like last name get obfuscated into like A or B or so. So you really have very, very compact code. And because it's Java, we have a scope. So in Java, you have functions. And in a second function, you can reuse the variable names you used before. So the compiler just knows about it and really optimizes all these, all these obfuscated names. So the alphabet usually doesn't run out. So you have A, and then you have B and C and so on. And you don't have to use A, B in most cases because, yeah, the alphabet is 26. So you can usually start using the A again in a different scope. So that's really a good thing. And yeah, of course, we've seen it. All non-essential punctuation, all spacing, all this kind of, make it nice looking stuff isn't important if you just want to execute the code. But of course, in Java, you have all your nicely layouted, all your nicely, punctuation and stuff, everything correct. This was the second part. So now to the third part, user interface. Let's have a look at a sample application that comes on board with Google Web Toolkit. Bless you. You've probably seen it. There is tabs, so you have contacts, tasks, and mail. And if you click on task, you will see your task. If you click on mail, you will see the mails and so on. If the default view was to start with, in this case, contact, there's no use of loading all the emails because, you don't see them. In Google Web Toolkit, for this kind of applications, we have the lazy panel. So it's basically, doing just like this, lazy loading. It just loads as soon as it's needed, as soon as it gets visible, as soon as it gets displayed. And you might think, okay, that's nice. I could probably do this by hand. But like at some point, it starts getting complicated when you have, okay, so when should I load it? And with the lazy panel, all this code comes for free. You just use it as you would use it normally. So you have tab contents, you create a widget and so on, and then you just work with the content. And all the when do we need to load it stuff gets handled by Google Web Toolkit. So really, really easy to use. And then, that code is more than JavaScript code. If you have huge CSS files, cascading style sheet files, in Google we did some tests to prove this assumption. The assumption is, okay, if you have a lot of empty classes that basically do nothing but add up to the classes that the cascading style sheets need to decide on. So we have A0, B0, and at the end we would use in some file, in this case 4,900, so we would use A 4,900, B 4,900, whatever. So basically during the runtime, the cascading style sheet would go down like this and finally find the right class. So we wanted to prove that it's true, and actually it is true. All these irrelevant classes add up because, we need to decide which is the right class. So what can you do about it? If you have an application, as we've seen before, with various tabs, and each tab has its own CSS, and you have like the settings dialog, for example, that most users probably never ever see, and if they see them, okay, they see it, but once, and next time, 90% of the visits, the people don't access the settings dialog. So what you can do about it? You can place seldomly used CSS files in separate files and disable them. So if you have a look at the above box, you can see an attribute disabled equals to disabled. So you simply have this script, have this file in your HTML, but you set it disabled, so it won't sum up to all the various decisions because you have disabled it. And once you use it, you can go like this. You simply get the element by the ID, so settings CSS, and you set the disabled value to true, to false, or however you want to have it. So it's really a great way of making sure that, well, you have all the CSS files, but you just enable the ones you need. This really can speed up your application if you have huge CSS files. And believe me, a lot of applications, if you have a look at main.css or whatever they call them, it's really a huge file because they need to basically make sure that all cases of, all states of the application have their right look and feel. So great technique. And also, if you have descendant selectors, so if you have a look at the example, .class, 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 this might happen if you have some really nested CSSing, where you say, okay, if it's this and this and this, it turns out that it's a lot faster if you simply, just, how to say, out-calculate this into .class, -class, -class. So you don't have this inheriting, but you just formulate it out into the separate files, separate classes. We've done some tests. Let's see. We have on the y-axis the execution time, and on the x-axis we have the number of separate classes. And with ID selectors, which is what we do in the .class, -class, -class case, you can see that it's really the fastest way to do it. With the class, with the other version, you can see that it's way slower. We have some nasty nesting. Probably you've seen it before if you've programmed Google App Toolkit. You have a panel inside a panel inside a panel inside a panel. Before you probably would have done it with tables if you write HTML by hand. In Web Toolkit, we call this panels. So you have a vertical panel, and in the vertical panel, you have a horizontal panel, and so on. So your nesting really gets nasty, and you kind of really are not sure anymore where you are. Why not just use HTML for this? And with the new Google App Toolkit, now you can actually do this. We have introduced the HTML panel. So now you can simply have, in Java, a new HTML panel, then you give it the HTML string, and still can be able to work with the object. So you can see two spans, so span ID, name ID, and the second one, span ID, company ID. And then in your JavaScript, in your Java code, you can just say P, which is the HTML panel, add and replace element, and then just give it the name and the name ID. So even if it's just an HTML string, you can still work with it. So it's really a great way of making sure that your nasty nesting gets a bit less nasty. And why is this important? I'm a web developer, but I'm not much of a designer. So in many companies, we have the same setup. So we have developers and we have designers. The designers deal with code like table, tr, td, and so on. They can really make sure that it looks nice, and we can make sure that it works correctly as developers. So in Web Toolkit, you can have this kind of setup. You just tell the design person, look, I need just two IDs, name ID, company ID, and you do whatever you want with it. So you lay out the input fields like this or whatever. And me as a developer, I just work with the IDs. So you can really split up the work process. So this was a summary. We have seen various techniques. Now it's time to go to a bit of code. Code.google.com/webtoolkit is the URL. I've prepared a live demo, which hopefully will work, but it's a live demo, so we never know. So let's see. I went to this page, getting started, and it's kind of hard to read here because the resolution is really low. This is how to create an application from scratch with Eclipse. I said before I want to use Eclipse, so I just used this tutorial. And basically what I did for this, I've copied all the steps in a text file so that I can cheat a bit and at least make sure that I won't mess up just by entering the code. So workspace, okay, we're in the Eclipse workspace folder. I start with making a new folder. I call my project Shalom Israel. Whoop, like this. So now I've made the folder. Then I cd into it. Shalom Israel, here we are. And then I run a script that creates an Eclipse project. So you do this only once, and basically it reduces to adding this line. So now we have the Eclipse project. And then we create an application, which is the second line, like this. And you can see, well, some directories get created, some files get created. That's all. So this is the command line stuff that you have to do. Now we go over to Eclipse. So I fire up Eclipse, which I did before. And you start with File and then Import existing project into Workspace. You go like this. And then you select the directory where you have put the file. So where were we? Document, workspace, Shalom Israel. This is the project we just created. And then choose. And then you can see there is a project in the directory, Shalom Israel. I go finish. And here we are. So now I have it in the project. I can open it and select the sources. And this is the first application that's like the hello world of Google Web Toolkit. So let's see how it works, how we run it, how it looks like. You go to Run, select the right runtime configuration, so Shalom Israel. And then hopefully we will see something. Shalom Israel, it's loading, it's compiling, and here we are. This is the hello world. I make it full screen. So you have click me. I click the button and you can see a nice dialog box. It was even animated, so you can see it opens up like this and it closes like this with an animation. And if you're doing Web 2.0 development, you really need like animations and stuff. It's just Web 2.0, so we have to have it. It comes for free with Google Web Toolkit. So now let's see how we can work with the code. I go back to Eclipse. This is the code. And now I can say, I replace the welcome to GWT by Shalom Israel. And save it. And then simply go back to here, refresh. I click the button, and now it says Shalom Israel. So this is really running in a hosted browser. So there's no need to fire up each time the Google Web Toolkit environment. You just hit refresh, as you would do if you program with a normal browser. So it's really, really a great way of programming. I've created another fast example to show you how easy it is to get started with Web Toolkit. Sorry? Yeah, sure. So he asked me to show the source code. Whoop. Now the Java bytecode gets created. Here we are. Well, I cannot really do it here, but this is running in the hosted browser, so it executes the bytecode. What we can do is we compile it and browse it. So we just click this button, and now it takes some time and really compiles Java into JavaScript. So hopefully, once this process is finished, Firefox will be fired up. Here we are. So this is the application now running in Firefox. So you can see it has switched over to Firefox. We can still test it. Shalom Israel. It still works. It still has the nice animation.
How come it's aligned to the right?
Sorry?
How come it's aligned to the right?
The question was, how come it's aligned to the right? Probably because Firefox is, yeah, it was in full screen mode when I used it on my laptop, but on the projector I have a smaller resolution, so it's really in the middle, as you can see now when I have put it to full screen. Click me, Shalom Israel, everything's still good. So now let's have a look at the source code. Whoops. It was already full screen. So this is just comments, basically, all the green stuff. And then at this point, we have the decision script. Israel, no cache. And that's it. So the HTML is really clean. And now we could go into like the decision script and see how it works. But you don't have to do it. If you're like noisy and really want to know how it works, you can always have a look at the script. But it's just really ugly, very compact JavaScript code. And that's the idea. You never ever touch the JavaScript code. You basically just work with the Java code. So this is how it looks like. Now I want to show you another example. Who of you has programmed a tree, like a tree widget in JavaScript? Some of you. How many lines did you spend for this? 1,000? 50? 50 is really good. I want to see your code. So we have 1,000 against 50. Let's see how many lines this are with Google Web Toolkit. I've prepared a small application, Hello Israel. Then I will run before. So I need to quit because now I'm changing the runtime. Whoop, run, and then I run Hello Israel. So I start showing off my super application that I've written for you. It's an application where you have Israeli cities. So it's a small tree, and you can see it counts the number of elements. So if I open it, it has 3 elements in there. There's Tel Aviv, there's Jerusalem, there's Haifa. Which city do we want me to add? Sorry? Modin. I'm not sure how to write it. Modin, like this? Whatever. Let's add this city. City successfully added. We have this dialog. OK. And you can see now we have 4. Which city? Well, this is maybe I should have changed the example because it's a bit of touchy to using this kind of formulation in Israel. So which city do you want me to remove? OK. Let me go like this. I come from Hamburg, so I add Hamburg. And of course, Hamburg is not an Israeli city, so we remove it from the tree. So you can see in real time we have the counter get updated. So how many lines do you think this took me in Java? 1? 1 is, I would be a genius if I would do it in 1. 4? Well, let's have a look at the actual code. I need to select the code. Here we are. Are you going to come with the injection? Let's see. So this is all the import stuff, some comments, some commented lines, some empty lines. So it's 87 lines. And remember what we had. We had an image that could, on click, remove some of the tree elements. We had an input text field that would add a tree element. We had the counting element that would always count the number of nodes in the tree. So let's quickly look how this works. We have onModuleLoad, which is basically the entry function. And the first block up to here just creates this small dialog box. So the box that appears when I click blah, blah. See, so this is the dialog box I'm talking about. Let's see how it works. We have a dialog box object we created. We set the text, city successfully added. We add a button to it. We have some like layouting, how it should look like. And then we have this close button, and on click, we just close the dialog box, so dialog box.hide. This is basically what happens, not really interesting. Let's have a look at the tree. We start with a tree item, root. This is, yeah, the root of the tree. And then we start with the tree, and to the tree, we add the root, so very logic. And then I have written a function add tree item to root, and then the city name. So let's jump into the function add tree item, which is here. So we have as entry parameters the root, and then the string, the city name. So we create a panel, because every tree element is the name, and then the small like X for closing or removing the city. So let's have a look how it works. We have this panel for holding them. Then we create a tree item, and to the tree panel we add the city label. Then we have a close image, and close image we have a click listener. So on click we would remove the item and set the HTML to the new child count. So we just count the nodes. Question?
Can it support progressive enhancement for users that don't have JavaScript?
I didn't really get the.
What I'm asking is, what about users that don't have JavaScript enabled? Does the kit support producing code that support progressive enhancement?
So the question was, how about users that have JavaScript disabled? And the second part of the question, does Google Web Toolkit allow you to handle this case? The question, the answer is not at present. Yeah, it's about Java to JavaScript compilation, so it's, yeah, if you haven't JavaScript enabled, it just wouldn't work.
Can it be used if I don't want to program in Java? Can I just use the components?
The question is, if you don't want to use Java to write JavaScript, so what do you want to use?
I would like to use the JavaScript library behind it. I already have a website, but now I want to plug it into inside.
Yeah, okay, so the question was, how about, like, I already have this website, it's very successful, I don't want to completely relaunch it and don't want to switch completely over to Google Web Toolkit. And the question is, can we just use, like, say, this tree in my already existing web page? And the answer is yes, you can. And why? By the way, yes, we can. Why is that? The only way where Google Web Toolkit gets inserted in this HTML page is by introducing this script. So you can just replace, well, you can just copy this line of code, this selector script, in your already existing page, and then work with your existing page, and at a certain, I don't know, div, or at a certain point in your website, just load the selector script, and then have just a small component of your website use Google Web Toolkit code. So we can really have various types of applications that use various components of Web Toolkit, or don't use them if you have something already running. I want to quickly continue the presentation and then at the end have some questions, if it's okay for you. Right? When is the session over? It's over? Oh. Okay. So this is the code. Let's see what happens interesting here. So now to the tree we have added the cities. And then basically we just add the input field. We have some magic. We have another on-click listener. So if you want, I can share the code with you. Email me afterwards. And so I have one last slide where I have my email address. So thanks for your attention. My email address, tomek@google.com, and we can have some questions now, hopefully. Very quickly, maybe. What about dynamic? Okay, so if you have the server side running and you, Yeah, basically, you can treat it like a normal web page. Like the example we had before, you have already running code, and you want to introduce parts of Web Toolkit in it. So it basically works the same. And it's Web Toolkit, so it's Java. It can easily work with your Java server backend, but you can also make it work with a PHP server backend. So you just need to agree on the APIs, more or less. And Google Web Toolkit comes with various ways of accessing the server. So it supports RPC, it supports like REST-based APIs. It's really general, so it's not limited to Java. Wow, there's many questions. So
your answer was to work side by side, my JavaScript and the GWT JavaScript. Is there a way to import JavaScript into GWT so I can work with it and see the methods inside the Java environments, my JavaScript?
So the question is, can I use JavaScript in Google Web Toolkit? Yes, you can. We call it JSNI, so JavaScript Native Interface. I have some slides. I don't really know if I should show this because we're really over time. But this is how it looks like. So we have this JavaScript function that flips the names. So you can basically just call JavaScript code inside of Java code. And now you're running Java. And you can do vice versa. Here, you can have Google Web Toolkit access external existing libraries. So I was talking about this great animations that you have in Web 2.0 applications. So most people use Scriptaculars or so. So you can have Scriptaculars. I think it's on the next slide. Let's see. Yeah, you can have Scriptaculars and Google Web Toolkit work together. So if you have this path effect that goes like path, this is how it works. You include in JavaScript the two libraries, so prototype and Scriptaculars, and then with the native JavaScript native interface, you just call window, which is the variable of the window object in the browser, .effect.path, and then you give it the ID. So it's really, really straightforward. Also mixing up existing JavaScript libraries with your new Java code. Last question. If not, we can always have emails. So your hand was up first.
One, can you give an example of a large-scale open source application that the reference is that? And the second one is the roadmap of
Okay, so it was last question, but two questions. The last one is easy because he was asking for the roadmap of Google Web Toolkit. The best thing you can do is Google Web Toolkit is open source. So you just browse the SVN tree, you just browse the issues list, you just have a look at the, well, basically the website, code.google.com/webtoolkit, and then you can see what's going on. You can see what people are discussing. So the roadmap is really open. So if you have something that you want in Web Toolkit, you just post to the forums, you just contribute your code into the tree, and yeah, then basically you can make sure the roadmap. The second, well, his first question, but my second question, my second answer now is, are there any examples of Google Web Toolkit in applications? Go to ajaxian.com, which is a great blog about Ajax, everything Ajax. Search for the label GWT, and there will pop up many examples. So thank you very much for your attention. I really like seeing you.